Hi everyone, welcome to GeoStat. Today I will discuss and calculate average depth of rainfall using the Thiessen Polygon method. This method is generally applicable for area ranging from 500 to 5000 square kilometer. We also use this method area having less than 500 square kilometer if we found outlier in the dataset. Generally, we use arithmetic mean method to calculate the average depth of rainfall for area less than 500 square kilometer. But if we found outlier in the dataset, we have to use Thiessen Polygon method to calculate the average depth of rainfall in a specific region over a particular time period. The link of the arithmetic mean method is given in the description. You can check to calculate the average depth of rainfall using the arithmetic mean method. However, Thiessen Polygon method is one of the most common method, also known as weighted mean method, because we give weightage to the rainfall of each station. This weightage is the area occupied by each station, and assuming that rainfall occurs uniformly within this area. This area is determined by drawing a polygons around the station. That's why it is also known as polygon method. But we call the Thiessen Polygon method because polygon was developed by a Dutch meteorologist Alfred Thiessen. And this method is accurate than arithmetic mean method because it reduces the effect of variability within the region by giving the weightage to the station. At the end of the slide, I will show you how it reduces effects of variability. However, the formula of this method is here. PAV equal to P1 into A1 plus P2 into A2 plus P3 into A3 plus up to the Pn and An divided by An plus A2 plus A3 plus An. Here, PAV means average depth of rainfall in a specific region over a particular time period. P1 means rainfall of station 1, A1 means area of station 1, and so on. And Pn means rainfall of nth station, An means area of nth station. Simply, we can write the formula as summation of P into A divided by summation of A. Let's draw the polygons around each station. These 4 points outline the procedures to develop polygons. So the first step is join the adjacent rain gauge station until triangle is formed. That means we have to join closest rain gauge stations each other to develop triangle. Let's try with these 7 stations A, B, C, D, E, F and G. So here A is closest to B, so join A and B. B is closest to C, so join B and C. C is closest to D, so join C and D. D is closest to C, we have already joined C and D. F is closest to C, so joined F and C. G is closest to F, so joined F and G. E is closest to G, so joined E and G. Still, triangle is not formed, so we have to join closest stations. B and D are closest, so join B and D. Now one triangle is formed. D, F are closest, so join D and F. Continue this process until triangle is formed. A and D, D and G, E and D. And at last, join all the remaining stations to develop triangle. Now, triangles are formed. The second step is that identify the middle point of the sides of all the triangle. You can use scale to find the middle point of the sides of all the triangle. So this is the middle point. These are all middle points of the sides of all the triangle. Now third procedure is that draw the perpendicular bisector of the sides of all the triangle. That means bisector's angle should be 90 degree. That means this angle should be 90 degree. This angle should be 90 degree. So all the bisectors angle should be 90 degree. This angle should be 90 degree. This angle also should be 90 degree. Remember here, intersection points of three bisectors, that means these points, these points, these points, all the intersection points should be within its triangle. For example, if this is a triangle, intersection point should be within its area, not outside the triangle. If intersection point fall outside the triangle, you can adjust the bisector angle. So you can adjust these angles. You can adjust these angles to keep the point within the triangle. Adjust means you can increase or decrease the bisector angle to keep the point within its triangle area. So now polygon is formed. This is the polygon of A station. This is the polygon of C station. And this is the polygon of D station. This is the polygon of G station. This is the polygon of E station. Now we have to calculate the area of each station. That means we have to calculate polygon area. So the area of A station is this one. Area of G station is this one. Area of C station is this one. You can use graph paper or planimeter to calculate the area of each of the station. So the final design will be look like this. The brown lines represent the triangles and blue lines represent the polygon. After that, you can also remove the triangles. If you remove the triangles, the design will be look like this. Remember here, the greater number of weather stations within the area of interest always increase the accuracy of the results. Also, we can consider weather stations outside the area of interest. Here, P1 and P5 are the outside the area of interest. These black lines are area of interest. So we can use outside weather stations to calculate average depth of rainfall, but we only consider polygon area within the area of interest. That means we only consider this area. We only consider this area. So let's calculate with these 5 weather stations. There are 5 stations, and these are rainfall of 5 stations, and these are area of these 5 stations. Here 8 means area of weather station 1. So this one. 9 is the area of weather station 2. So this polygon area is 9. Now according to the formula, A into B, so 80, 45, 80, 42 and 40. The summation of A into B, 287. The summation of area, 37. You can also calculate area weighted rainfall. The formula of area weighted rainfall is that A into P divided by total area. That means 80 by 37, 45 by 37. so on. If we sum up the area weighted rainfall, we get the average depth of rainfall. Also, according to the formula, PAV equal to summation A into V divided by summation A. That means 287 divided by 37. 7.76, the average depth of rainfall. The problem with this method is variability. I already told this method is less affected by variability compared to the arithmetic mean method, but still it is influenced by variability. For example, you can see here area of rainfall of weather station 1 2.16 and 2.16 for weather station 3. But here you can check rainfall of station 1 is 10, that means greater than station 3, but area of rainfall is same. That means this method is influenced by variability of rainfall. However, these methods help to reduce effects of variability as compared to the arithmetic mean method. Check this slide. These are 5 weather stations. These are the rainfall. So according to the arithmetic mean method, the average depth of rainfall is 6. Average depth of rainfall using Thiessen Polygon Method is 4.90. So it reduced the effect of variability. Variability means outlier. The rainfall of station 5 is 19. So average depth of rainfall using arithmetic mean increased to 6. But Thiessen Polygon Method reduced it to 4.90. So it minimizes the effect of variability. However, as I mentioned earlier, this method is still affected by outlier or variability. So in larger area, basically area having greater than 5,000 square kilometer, we should always use isohydrate method. In the next video, I will explain the isohydrate method.